Now today we will see how do we graph sine or cosine functions, but today we're really going to concentrate on sine. Now let's see. The main idea today is that if you want to graph a sine or a cosine function, you need to know two key properties of those functions, which is the amplitude and the period. Now, in order for you to find the amplitude of a trigonometric function, you need to find the highest point and you're going to subtract the lowest point. So the amplitude of a function is high point minus low point, and then we will divide that by 2. If you want to find out the period of a function, we just need to find out the length that is needed in order for the function to have a complete cycle. So these are two key properties that we need to keep in mind whenever we're graphing any kind of a sine or cosine function. The amplitude is the high point minus the low point, the highest point in the graph. We will subtract the lowest point in the graph and then we will divide by 2. And the period is just how long it takes for the graph to complete a full cycle. Now let's start with something basic. Here we have a table of values. Let's try to fill in this table of values in order for us to graph a sine function. So we're going to fill in the table of values, and then we're going to put those coordinate points in the plane. So let's see. So let's fill in those table of values. Now, how do we read this table? Well, it says here that, or the value of the angle is going to be placed on the bottom row and the angle on the top. So how do we first need to fill in this table? How do we fill it in? We're going to find the sine of every angle that it's here. So to find this value, we need to find the sine of 0 degrees. So let's do sine of 0. We have 0, so we have 0 here. So now let's find the next value, sine of 30. So we're going to have sine of 30 equals 0.5. So we got 0.5 here, 0.5. And we're going to fill that in for all the values here. So let's do one more. So the sine of 45, which is 0.7. We will fill in the values for all these tables. So let me pause the video. Let me put the values, and then I'll come back in a second. All right, so we're back. Now, here is the values. Now, here are the values that we found in our calculator. So now we are going to try to put these values in our graph right here on the bottom. So how do we read the table in order to find coordinate points? Well, when we're graphing any kind of trig function, your x-axis is always going to be your angles. And the y-axis is the actual values. So let's see. Here it says that when the angle was 0, the value was 0. So we're going to have a point here at 0, 0. Now let's see, what was the value when we had 90 degrees? Well, when it was 90 degrees, our value was 1. So at 90 degrees, my value is 1. Okay. So our value was 1. Let me just increase this. Maybe that's why it's... Our value was 1. So now let's look at our next point, 180. When my degree was 180, I had a value of 0. So 180, I had 0. So let me make this bigger. 180, we had 0. So I'm just plugging in some values that we have here on our table. At 270, which is right here, our value was negative 1. So at 270, our value was negative 1. So at 270, negative 1 here. At 360, we come back to 0. At 360, we come back to 0. All right, so let's just connect those points. Let's see. We have a graph. Well, I don't like purple. Let's go with blue. So Okay, so here's our sine function. Now, I know that my graph looked like a curve because we have seen the graphs of sine and cosine. We talked about that sine always looks like a curve shape, a smooth shape. So all I needed was just the points. So we're just going to have a curve shape here. So now that we have those points, we can actually start answering some questions here. So let's try to see. Let's try to answer some of the questions here. Now let's identify, let me erase this. Remember the x-axis was your angles. And so now here let's try to identify the period and the amplitude of the function. Now again, at the beginning, we stated that the amplitude is equal to high minus low divided by 2. So now let's see. What's the highest point that my graph reach? Well, notice that this is the highest point that my graph reach, which is 1. So we're going to have 1 minus. And what was the lowest point that my graph reached? This is the lowest point, so what's my value? -1. So we have 1 minus -1 divided by 2. Minus a minus, it becomes plus. So now it becomes 1 plus 1 divided by 2, which is 2 divided by 2, which is just 1. So we know that the amplitude is 1. Now, let's find the period. Now, the period of the function is how long it took for my function to complete one full cycle. So let's see. Let's say we start here at 0. Let's do this in orange. Let's say we start here at 0. So now, notice that our graph, it goes up, and then down, and then it comes back to 0 again. But does it have the same shape? No. So notice that my graph continues here, and then it goes up again, and then it reaches 0. And if we continue this function, my function will still continue with the same shape. This is just an estimation. And then it will continue going down and then up again. How do I know that? Because we know that trig functions are periodic functions. So how long did it take for my graph to complete a full cycle? We start at 0, we reach 0 again, but we notice that we're covering new y points. So we go again, and it takes 360 degrees for us to have this shape, because we know that after this shape, our graph is going to have the same shape over and over again. So it took us 360 degrees in order for us to complete a cycle or to complete a period. Now, let's identify the relative max and the relative min. Now, what is the relative maximum? The relative maximum is basically what is kind of like the highest point. All right, so what's our high point maximum? So notice that here our highest point was 1. So it says that we have a maximum. We're going to give the whole coordinate point. Our maximum occurs at 90 degrees when a value is 1. So we have a maxima at 90, comma 1. And when do we have a minima? Well, here's our lowest point. This happened when we had 270 degrees. So it says that my relative min, or the lowest point, is at 270, comma, -1. So this is relative max. Now, for relative min, Okay, so for relative min is the lowest point. The lowest point occurred at 270, so we have 270, comma, -1. 270 degrees, comma, -1. Now, let's see. Let's identify the intervals where my graph is increasing. So let's look at our graph. When is our graph increasing? Well, our graph is increasing. Notice that here in this interval, let's do this in blue again. In this interval, my graph is increasing until it reaches this point. After this point, the graph is decreasing. Then once it reaches this point, it starts increasing again. So in these blue intervals, these are the intervals where your graph is increasing. So all we gotta do is just write it down. I mean, when is my graph increasing? It was increasing from 0 degrees until it hit 90 degrees. So let's write that down. Identify the intervals. So from 0 degrees to 90 degrees, that's one of the intervals. And what was the other interval? From 270 all the way to 360. And what were those intervals again? 270 to 360. From 270 degrees to 360 degrees. There it is. So these are my intervals where my graph was increasing. And lastly, let's identify where is my graph decreasing. So now the decreasing, let's do it in red. Again, notice that my graph is going up, 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 up. And once you reach this point, it starts going down. So our graph is coming down. This is where my graph is decreasing. And once it reaches this point, then it starts increasing again. So the interval where my graph was decreasing was from 90 degrees all the way to 270 degrees. So let's write that down. So the interval from decreasing is from 90 to 270. So we have from 90 degrees to 270 degrees. These are kind of some of the key properties when we're trying to analyze any kind of a trig function. We need to identify the period, the amplitude, where is my graph increasing, where is my graph decreasing, and the relative max and the relative min. So now, here's your entrance ticket.